The following presentation will be on decision trees. This topic will be on your next assessment, but it's a topic we won't cover in class until a later date. So it's important that you watch the presentation, make any notes, and then ask any questions in class that you don't understand. So the first question is, what is a decision tree? A decision tree is a mathematical model which can be used by business managers to help them make the right decision. So often a manager can be faced with a variety of choices. So how do they go about choosing the right option? This can be difficult, and basically a decision tree will help with the process, as on a diagram it will show the financial consequences of each option. The obvious choice for the manager will then be to pick the option which is the most financially viable for the business. A decision tree starts with a square. The square signifies that a manager is faced with a possible choice of different decisions. These possible choices facing the manager are shown on lines coming off the square. So here the manager has three possible choices. Let's say the first one facing the manager would be to reduce the price of the product. So the choice facing the manager is indicated above the line. So this would signify the first option to cut the price. The other option that the manager could choose could possibly be spend more money on advertising. So increase spending on advertising. And the third line just represents that the manager could do nothing, because it's still an option that the manager faces. So it still needs to be shown on the decision tree. So here we have the square, which is the start of the decision tree and shows that there are choices to be made. The choices shown are via the lines coming off the square, so cut price, increase advertising, or do nothing. Once the choices are there, then the decision tree will show the possible outcomes of each decision. These outcomes will be shown by a circle. The circles are at the end of the lines, and then the outcomes will come from there. Just line these circles up so they're in place. Because the third option is to do nothing, there are no other outcomes. So there are no possible outcomes, it's just do nothing. So we don't need a circle down here, so it's just the two. So that's the decision tree so far. So we've got the start, which signifies the manager faces a choice. We've got the lines, which show the choices that the manager has to make. So should the price of the product be cut? Should the amount spent on advertising be increased? Or should the manager simply just leave it for the time being and do nothing? So now that we have the options shown on the decision tree, we can start to add some likely outcomes of each choice that might be made. So, the likely outcome of each one occurring will be shown after the circle. We use probability to highlight the possible outcomes of each decision. So, there's the likely outcome that if the price of the product is cut, this could lead to high sales. But there's also a chance that if the price of the product is cut, it could lead to low sales. So these are the two possible outcomes if the manager were to choose this option. We also need to add the outcomes for this option, so increase advertising. So if the business decides to increase advertising costs, there'll also be likely outcomes. These outcomes could be, again, a result of an increase in sales. So again, this could lead to high sales, or could lead to low sales. So how do we determine what the outcomes might be? Well, for these options we use probability. So the probability has to add up to 1 for each likely outcome. So there's either, for example, an 80% chance that this could lead to high sales, which would therefore mean that there would be 20% chance it would lead to low sales. So when doing probability, we put the number or the likelihood of the outcome occurring underneath the line. So let's put in some likely outcomes and some figures, probabilities. So for high sales occurring, we'll stick with the 80% chance. So when we do probability, it must add up to 1. So we will use 0.8 for high sales. So this would signify 80% because it's going to add up to 1. So therefore, low sales would be 0.2. This is exactly the same for this option. Again, we need to put in the likely outcome underneath the line. Underneath the line we will use probability, which must add up to 1. So we will say that there's a 50-50 chance that if advertising increased, it will lead to higher sales. So a 50% chance in terms of probability would be expressed as 0.5. So therefore, low sales would also be 0.5. So now we have, a quick recap, the square to start the decision tree, the options available, which are to cut the price, increase advertising, or do nothing. And then the circle signifies that there are possible outcomes. And we've now put the outcomes on there, which is expressed as probability, which must add up to 1. So each outcome must add up to 1. So this is one separate outcome, and this is obviously a second outcome because it's for a different option. So we have 80% chance of high sales, which is therefore 20 of low. We've got 50% of high sales, which has obviously then got to be 50% low sales, because these two should always add up to 1. So, where we have the probability of high sales and low sales occurring for each one, on a decision tree you will be given the actual figure for what the high sales figure might be and what the low sales figure might be. So for this example, what we will say is that if the price is cut, there's an 80% that high sales will occur, which will lead to an increase in revenue of 8 million. So we'll put 8 million. But because there's a 20% chance of low sales occurring, this means that it will only lead to a 3 million increase in revenue. So these are the revenue figures, not profit. So it will lead to an increase of 8 million revenue, an increase of 3 million revenue. And this needs to be done also for the second option of increase advertising. So there's a 50% chance that high sales will occur. So there's a 50% chance that revenue will increase to 10 million, but there's also a 50% chance that it might only lead to an increase in revenue of 2 million. So, if the manager makes the decision once to cut the price, so he makes the decision one time, there's an 80% chance that revenue will increase by 8 million, but there's a 20% chance that it might only increase by 3 million. This is the same concept for increased advertising. High sales might happen 50% of the time, which will lead to an increase in revenue of 10 million, but then there's a 50% chance that low sales might only lead to an increase in revenue of 2 million. So, what we want to know though from a manager's point of view is, what if this decision is made over and over again? So yes, one time this might occur, or this might occur, but what about if the decision is repeated over and over again for each one of these? Well, that's where we bring in the concept of the decision tree, and we can work out what is known as the expected value, which is basically the average figure, so the average revenue gain that will occur if this decision is made over and over again, or this decision is made over and over again. So I will now go through with you on the next slide how to calculate the expected value. So I've reduced the size of the model, but it's still the same one that we've just been looking at. And on this side, I'm just going to go through with you how to calculate the expected value, which I just said was basically the weighted average. So if you were to make the same choice over and over again, what would be the average increase in revenue? So not the one-off 80% chance of it being 8 million, or the one-off chance of 20% of the time it being 3 million. Basically the average if we were to repeat this over and over again. Okay, so to do this we use a formula. And the formula is basically the probability. So it's the probability of outcome 1, which in this case is high sales occurring. So it's the probability of outcome 1 occurring multiplied by the outcome, which in this case is the 8 million, plus the probability of the second outcome, which is the low sales, times the outcome of this option, which in this case is 3 million. So the sum that we would do to work out the expected value, so the average of cutting the price, would simply be to do 0.8 times 8 million plus 0.2 times 3 million. So this would give us, when we calculated it, the average outcome of what the expected value would be if this process was repeated time and time again. So in this case it would be 7 million. So the 7 million is known as the expected value. So the weighted average of this decision. The expected value should be recorded above the circle. So above this circle here we can put in EV equals 7 million. So why don't we have a go at calculating the expected value now for the second option. So we can clear this bit here, and then we can start again. So it's the same formula. So it's probability of 1, 0.5, times the outcome of 1, which is 10, plus the probability of 2, which is 0.5, times the outcome, which is 2. So let's record that. So we've got 0.5 times 10 plus 0.5 times 2, which will equal 6 million. So it will equal 6 million. Again, we'll record this 6 million above the circle. Right, so we've now done the expected value. An important point to make is that the expected value is not the profit figure. This is the probability times the revenue, which has given us the expected value. So on average, if we were to choose this decision over and over again, we should expect the average gain to be an increase in revenue of 7 million, and for the second option of 6 million. However, business studies students, we should know that this is not the profit figure, simply because we need to deduct the cost of each one from the revenue average. Okay, so as you can see, there's no actual costs on here, but the costs will be given to you, and they are usually displayed. So if you are given the decision tree with the information on, the cost of each option will be displayed underneath the original option, what it was. So underneath the arrow would be the cost. So the cost of cutting the price in this instance would be 1.5 million, which would be under the line. Let's say that the second option, so the cost of increasing advertising, would be 4 million. So now that we know the expected values and the cost, we can work out what is technically the product, but what we call when doing decision trees as the net gain. So it's called the net gain. What will be the overall gain once all costs have been deducted? So it's a simple formula really, it's just the expected value minus the cost. So the net gain of choosing to cut the price would simply just be 7 million minus 1.5, which is going to give us a net gain for option 1 of 5.5 million. And exactly the same for the second one. We've got an expected value of 6 million, but the cost involved is 4 million. So the net gain for the second option would simply be 6 minus 4, which is going to give us 2 million. Now that we've worked all of this out, we can clearly see that based on the numerical data given in the decision tree, And by doing some calculations of the expected value and net gain, the manager can determine that the best option would obviously be to cut the price, because this is the one that gives the highest net gain, which is basically what we're looking for as a business, the one that's going to be the best gain for that particular business. So in this case, as a result of the decision tree, the manager would choose to cut the price. Okay, so here's another decision tree that I've imported from an example using the past for students. So basically, this is based on a farm which has two decisions to make. They can either introduce a campsite with fellow farms on 1 acre of land and farm the rest as normal, or they can continue with farming only. So remember back to the one that we've gone through. The square signifies that there are options to potentially choose. The lines will then show what those possible choices are. Then we have the circles, and from the circles the outcomes will be displayed. Remember, these are expressed as a probability, so they must add up to 1. So we've got 0.9 and 0.1, which adds up to 1. 0.9 obviously standing for 90% chance, 0.1 standing for 10% chance. Same with one below, we've got 0.6 and 0.4, which is obviously a 60% chance of success, a 40% chance of failure. And then we have the likely increase in revenue figures given to us. Remember that we are also given the cost underneath each option of choosing that particular option, which will be needed for calculating the net gains at the end. So, question number 1 asks for the expected value, so the EV, for both possible options. So it wants us to work it out for both. So, we need to remember the formula, which is basically the probability of outcome 1 times their likely gain plus the probability of the second option times the likely outcome. So in this instance, for number 1, we would do 0.9 times 1 million plus 0.1 times 10,000. And this will give us our expected value for this particular choice, meaning the average if we were to repeat this decision over and over and again, not just one time. Just working that out now, double checking the figure. So that looks like it would give us 901,000. If my maths is correct. Just double checking that figure. Which you should always do in an exam. Double check your workings. So 901,000. Then we need to do the same, because it's asking for both, for the second choice, which is to continue with farming only. So we would do 0.6, so 60% chance of the increase being 75,000. Put a K for 1,000 plus 0.4 times 20,000. And that will give us the expected value for the second choice. So if that decision was made over and over again. So that works out to be 53,000. So remember, the EVs would be placed above the circle. So the EV figures you would insert above the circle for the first one, above the circle for the second option. So that's the EVs calculated. However, as we've discussed, this is not the profit figure. So the question asks for the net gain for both options as well. So remember, to work out the net gain, it was just the expected value which we've calculated minus the cost of each potential choice. The cost located underneath the choice, or the possible choice. So the first one is simply 901,000, which is the EV, minus the 5,000, which gives us net gain of 896,000. So we'll just record that. So number one, net gain is 896,000. And now we can do the net gain for the second option. So the net gain is again the expected value, which in this case is 53,000, minus the cost, which is given to you underneath the line, which is 3,000. So therefore it's simply 50,000. So the final part to answering the question, which asks here, state which option they should choose. Well, clearly option number one, to introduce the campsite, is obviously the better choice because the net gain is massively, substantially higher than the second option. So 896,000 to 50,000. So therefore it's clear from the decision tree that the best choice to make based on scientific data and numerical data would be option one, which has an expected value of 901,000 and a net gain of 896,000. Right, I'm going to draw one more now, which I would like you to do for practice in preparation for your assessment. So, simple, start with a square. Now we can put the potential choices, so we'll just use the format of two options with the bottom one being do nothing. Obviously in the exam you might be given one where there's potentially 3 or 4 different options. We'll change the choice a little bit, so we'll say that there's either the option to launch a new product or to increase spending on advertising on current products. Right, so then we need to put in the circles, which will then represent the likely outcomes coming off these for these two potential options. So remember, these come off the circle. as such. And we don't need any for the bottom one because there won't be any outcomes from doing nothing. Right, so we'll put in the likely outcomes. So we've got high and low, high and low. We'll put in the probability of each one occurring, so we'll go with 0.6 of high, which means that this should obviously be 0.4, as it must add up to 1. And then here we'll go with a 0.7 chance of it being high and only a 0.3 of it being low. So there we have our probabilities. Okay, so now we need to add in the likely outcome, so the actual figures. So what might be this? What might the revenue increase to? So there's a 60% chance that if we do launch a new product, that revenue will increase by 2.1 million. But then there's a 40% chance that it might only increase by 500,000. Same for the second option, increase spending on advertising. There's a 70% chance that revenue might increase by 1.6 million. But then there's a 30% chance it might only increase by 750,000. Right, so the only last little bit of information missing for you to be able to work out these is the cost of each option. So, to launch the new product, the cost for the business will be 900,000, whilst the cost for increase in advertising will be 550,000. So now that you have the information regarding the revenue, the probabilities and the costs, I would like you to have a go at calculating for me, please, both the expected value for both options, so that's 1 and 2, and also the net gain for both options, 1 and 2. So just remember the formula, the expected values, 0.6 times 2.1, etc. And then remember, to get the net gain, all you do is subtract the cost from your expected value. Remember that your expected value should be clearly marked above the circle. I will go through this, or go through the answer to this on the next slide. So pause the video, do the working out, and then you can self-check your answer from my answer that I will shortly put together. Okay, so here's the decision tree that I gave you, and I asked you to calculate the net gain and the expected values for each option. So we've got the launch new product, and we've got the increased advertising. So I'll put all the information onto the board that you've got there. So we've got the cost, we've got the probabilities, and we've got the expected increase in revenue. So I'm going to do the expected value for the launch new product first. So all I'm going to do is 0.6 multiplied by 2.1 million plus 0.4 times 500,000. This should give me an expected value for the launch new product. So if we do the calculation, .6 times 2.1 million plus 0.4 times 500,000 gives us 1.46 million. for 1.46 million. So remember what I showed you in the presentation, where to put the expected value. So it's above the circle. So we're going to put the expected value here above the circle. So it was 1.46 million. So there's the expected value. Now we'll do the same for the second option, which is the increased advertising. So there's the first one. Now we'll do the second one. So it's going to be 0.7, which is this figure here, multiplied by 1.6 million plus 0.3 times 750,000. So that should give us the expected value for the second option. Let's just work that out. So 1.345 million. 1.345 million. So again, we'll record this above the circle. So 1.345 million. Okay, so now we've calculated the two expected values. So check them, tick them if you've got them right. However, as we said, that this is not the profit, so we wouldn't make a decision as a manager based just on the expected values, because we need to work out the net gains. Remember the formula? So it's just the expected value minus the cost, which is always given to you below the option. So minus the cost, okay, for each one. So now we can determine which one will be the best in terms of net gain. So 1.46 million for the first one. 1.46 million. Okay, minus the 900,000. It's going to give us 560,000. So the net gain for this first one would be 560,000. We do exactly the same for the second one, so we've got the expected value. Okay, so we've got the expected value, which is 1.345 million. We must deduct the cost, which is 550,000, which will give us the net gain for this option. Gives us 795,000. Okay, so 795,000. So again, I'd like you to check the figures for me, please. So you should have expected value for both and the net gains for both. So all that's left now to say is to tell the examiner that option 2 would be the best decision to make for the manager, as it will give the highest net gain, as we can see from these two options. And that's the decision tree format for you.